This is Dr. Mohan. I am from EC Department of Institute of Aeronautical Engineering. Our course title is Signals and Stochastic Processing. Today, we discuss about the property of Fourier series. This is the second section. Previous session, we studied for the property of Fourier series in linear property of continuous time Fourier series, conjugate property of continuous time Fourier series, conjugate symmetry property of continuous time Fourier series, time shifting property of Fourier series. These are the things we studied for the last session. In this session, we should go for the time reversal property of Fourier series, time scaling property of Fourier series, time differentiation property of Fourier series, time integral property of continuous time Fourier series, conversion property of continuous time Fourier series, Parseval theorem and Parseval identity. These are the property we should go for this session. First, we go for the time reversal property of Fourier series. So, we take for the x of t is a periodic function with fundamental period is represented as a capital letter T. The Fourier series coefficient I should write as a C of n. Then, as per the Fourier series condition, x of t you take for the Fourier series, then it's produce the output as C of n. At the same time, if you take for the inverse Fourier series of C of n, it's getting for the x of t. The time reversal property of continuous time Fourier series state that if time signs are getting to change in the input signal of continuous periodic signal, I should write for the inverse of time reversal is represented as x of minus t. So, x of t is represented as a continuous time Fourier signal that will be have the periodic, that is a periodic nature. The fundamental period is represented as a capital letter N. That will be have the characteristic of x of t. Now, what I am doing? So, we take for the t, this t we should make for the reversal, that is plus to minus. So, if we make to minus, then what will be happen? We get for the x of t minus. We take for the Fourier series, if the time is going to reversal, that's why what will be going to happen for the here in the case of Fourier series transform condition. So, A is a plus, that's why here also be plus, C of n also will be going to the plus. So, here is a minus, that's why. So, the x of minus t, that t is a minus, that's why the n also getting to minus. This is represented as a time reversal property of Fourier series. We can make to prove for the time reversal property. First, we should write for the continuous time Fourier series expression. The x of t is equal to summation of n equal to minus infinity to plus infinity of c of n e power j n omega 0 t. Now, we can replace for the this t into minus of t. So, I should write here the t into minus of t. Then the equation, what will be going to happen? Where the t is present, then I should change for the minus of t here. Then what about the next case of expression, the Fourier series, summation of n equal to minus plus infinity c of n e power j n omega 0 minus of t. Here also I added minus t. Now, I should take for the minus t is equal to minus of k. So, because of we need to express for the time reversal property, that's why I should take for the n equal to minus of k. Then, in the RHS of the equation. So, now what will be happen? What will be? So, here n is there, that's why I write for the minus of k. Okay, right side only. I take for this right side form. Next case, minus of t is there. At the same time, here is how the minus of n, plus of n is there. So, I should write as a minus of k. Now, I can simplify for this equation where the n is present, I should write for the minus of k. So, x of minus t is equal to k equal to minus into plus into. Here, I write for the minus of k. Then, this minus getting to plus of k. So now the expression is going to change as summation of k equal to minus infinity plus infinity c of minus k e power j k omega 0 t. Now again I make to write for the substitute k equal to n in the equation. Now where the k is present, I should substitute for the n. Now I make to write as I take to make to write as like this one. This equation into x of minus t is equal to n equal to minus infinity plus infinity. Here is I change for the k. So n equal to minus infinity plus infinity. Here it's I represent as a c of minus k e power j n omega 0 t. Now we can watch this equation. What is that Fourier series? That is represented as a summation of n equal to minus infinity plus infinity c of n e power j n omega 0 t. We write. So I should write as a x of t. We take for the Fourier series. We write for the c of n. This c of n, what will be going to? Here also n is there. Here also n is there. So based on that condition, I should write for the Fourier series coefficient. Same like that one. Here we have the minus of k. Here is plus n. So what the name? What the thing is present for the as usual your Fourier series? We should write like this one. So now the Fourier series of x of minus t is represented as a what will we have minus of k. This k we consider as a n. So now Fourier inverse of c of capital letter c of minus n I write. Now we should prove for if the time shift is going to happen, that is a time reversal is going to happen in the minus of t, then if we take for the Fourier series, we get for the c of minus n. This is capital letter, this is a small letter. Okay, this is a differentiation is represented as a, this is a small letter of n, then this one is represented as a capital letter of n. Hence, the time reversal property is getting to proved. Next property, time scaling property of Fourier series. So we take for the x of t as a periodic function with fundamental period is represented as a capital letter T. We take for the Fourier series, then we produce for the Fourier series coefficient as a c of n. As per the statement, we take for the Fourier series of x of t is equal to capital letter c of n. Then as per the statement of the time scaling property, in the sense where the time is there, we must multiply with some constant. That constant is represented as a linear constant. That linear constant I should take for the a. As per the case of time scaling, where the time is present, we multiply with the a. So now the time scaling property of continuous Fourier series I should write as a x of at. Here only is of the time. So see here the time. That's why I multiply with linear constant coefficient value of a. So x of at take for the Fourier transform. Then it's represented as a c of n. At the same time with omega 0 it's make for the time coefficient multiplication is going to happen. Now x of at take Fourier series, then c of n with omega 0 is converted for the a omega 0. That's why simply we write as a omega 0 tends to a omega 0. Now we go for the proof. From the definition of continuous time Fourier series, I should write the x of t is equal to n equal to minus infinity plus infinity c of n e power j n omega 0 t. Now where the t is present, we should add for the at in the equation. Okay, that will be, we need to add, that means x of t. So this is x of t, we can substitute for the at. That is equal to n equal to minus 2 plus c of n e power j n omega 0 at. Here I need to change. Then after x of at is equal to summation of n equal to minus infinity plus infinity c of n e power j a omega 0 t I should write. Okay, a omega 0 t. So now what will be happen? This is equal to omega 0. We write for the statement. What the statement we write? X a of t. Take the Fourier series, we get for the capital letter c of n, but with omega 0 is equal to a omega 0. I should write like this one. Okay, this is omega 0 tends to a omega 0. Then I should write for the uh, time constant case of Fourier series x of at is equal to Fourier inverse of c of n. Therefore, we make the statement of if we multiply with the any linear constant coefficient in the time, uh, after taking the Fourier series, we get for the Fourier coefficient is represented as Cfn when omega is equal to a0 omega. Hence, the property is getting to proved. Next case, time differential property of Fourier series. We take for the x of t as a periodic signal with fundamental period is represented as a capital letter T, and Fourier coefficient I should write as a C of n. If the Fourier series of condition x of t take for the Fourier series, we get for the C of n. The time differential property of continuous time Fourier series is represented as a differentiate with the x of t in t based, that is d by x of t divided by dt. After taking the Fourier series, it's multiplied with the Fourier constant as a jn omega 0. Then I should write for the differential property of Fourier series is represented as a d by dt x of t take Fourier series, then jn omega 0 into c of n. We write. This is a statement of time differential property of Fourier series. Now we need to prove for the time differential property of Fourier series. By the definition of continuous time Fourier series, we write as a x of t is equal to summation of n equal to minus into plus into c of n e power jn omega 0 t. Now I take for the both the side differentiate with time. So the left side I should write as a d by dt x of t is equal to n equal to minus 2 plus into c of n. This is a constant. That's why we can't do anything. So we take it out the c of n. Then after, where the differentiation is going to happen, we done for the based on the time period. So that's why d by dt into e power jn omega 0 t. Now this right side only is possible to do for the differentiation, but left side will be represented as a statement d by x of t divided by dt. Now we can differentiate with the t in the terms of e power jn omega 0 t, in the sense this is a coefficients. We take it will be represented as a jn omega 0 if we make to differentiate. Now the equation is consist of summation of n equal to minus into plus into c of n e power jn omega 0 t into jn omega 0 t. Now we can think what is this represented as a c of n. Okay, we represent as a c of n, we can write. So now d by dt x of t is equal to summation of n equal to minus into plus into in bracket I write as a jn omega 0 c of n e power jn omega 0 t. So now I modified for the equation like this one. What will be happen? What the condition, what the differentiation is going to happen, the e power jn omega 0, that will be came for here jn omega 0, that c of n is going to similar. So I write as a x of t is equal to summation of n equal to minus into plus into x of, that is c of n e power jn omega 0 t. That x of t we take for the Fourier series, we write as a c of n. Now in this c of n as a differentiation, time differentiation case, if we differentiate with the e power jn omega 0, this coefficient is came for the multiplication. So that multiplication I write as a jn omega 0 with multiplied with c of n. So that's why finally we made for the differentiation with time of a Fourier series represented as a d by dt x of t Fourier series is represented as a jn omega 0 c of n. Hence the property is getting to proved. Next case, time integration property of continuous time Fourier series. If x of t we take for the periodic function with fundamental period is represented as a capital letter T, and the Fourier series coefficient we write as a c of n, then x of t we take for the Fourier series is represented as a c of n. So for here all the property, all the things we take for the periodic signal only. So why? Because of the Fourier series going to satisfy for the only periodic signal. This periodic signal, the fundamental period we taken for the capital letter T. Okay. After next period, it will be repeated for the same characteristics of signal. That's why we may write for the Fourier series signal x of t is represented as a C of n. Now we take for the time integral property of continuous time Fourier series is to state that integration of minus infinity to plus t x of tau d tau. So instead of t, I should take for the tau because of it will be need to some differentiation in the t as well as of tau. We take for the Fourier series, then its producer output is represented as C of n divided by Jn omega 0. But C of 0 is equal to 0 for initial condition. If we take for the integration, C of 0 will be getting to 0. But in the case of differentiation, not like that one. The C of 0 also consists of some value. So what will be difference between the time integration as well as of time differentiation property? Time differentiation property is multiply with Jn omega 0, but time integral property is divided by the Jn omega 0. Yeah, this is the difference between the time integral as well as of time differentiation property. Now come to the time integral property. The time integral property which said that integration of minus infinity to t x of tau d tau f of s, that will be I write as a C of n divided by Jn omega 0. Now initial condition is 0. We need to prove that property. By definition of continuous time Fourier series, I should write as a x of t is equal to n equal to minus infinity plus infinity C of n e power j n omega 0 t. Now we take for the time integral for both sides. Okay, here I write for the integration of minus infinity plus infinity x of tau d of tau. Now I change for the t into tau. Then integration of minus infinity to t, summation of n equal to minus infinity to plus infinity C of n e power j n omega 0 tau d tau. Where the t's are there, I replaced. Okay. Now what will be represent what that equation is referred. So here both the side, left side as well as the right side, I make to integrate with respect to tau case. So integration of minus infinity x of tau d tau. Here I write. We received for this one is received for the signal x of t as a periodic signal. Now we done for the integration. Then right side also we may add for the integration minus infinity to t summation of n equal to minus infinity to plus infinity C of n e power j n omega 0 tau d tau. Here we mention for the t. So why we mention? Why? Because of our case converted as a tau to t. That's why I write as a t here. We need to end or terminate the interval is a capital small letter t. So next I make to rearrange the integration for right side. If I rearrange, what will be happen? Summation will be taken out. So right side what will be happen? N equal to minus 2 plus C of n minus infinity to t e power j n omega 0 tau d tau. If we make to integrate for this portion, what will be going to happen? This is going to have the constant. That's no problem. Summation of n equal to minus into plus into C of n we take it. So that is, if we make to integrate for this portion, e power j n omega 0 tau divided by j n omega 0 tau is a minus infinity to plus t. Now we need to substitute for the limit minus infinity to plus t. So this right side summation of n equal to minus infinity plus into C of n. This one is represents a plus t. We can substitute for e power j n omega 0 t divided by j n omega 0 t minus of e power minus infinity divided by j n omega 0. E power infinity is equal to 0. Okay, 0 divided by j n omega 0 is represented as 0. So I should write the equation as for the right side summation of n equal to minus into plus into C of n e power j n omega 0 t divided by j n omega 0. So this portion getting to 0. So remaining what we are going to have, we take it. So finally I write as a integration case the summation of n equal to minus plus into C of n divided by j n omega 0 e power j n omega 0. So this term I should write for the Cn Jn omega 0 summation of n equal to minus plus into Cn Jn omega 0 e power Jn omega 0 t is equal to Fourier inverse transform of C of n divided by j n omega 0 t. If we take, we get for the x of integration of infinity to t, x of tau d tau we got. This is a case we represent as a time integral property of Fourier series. Finally, I should write as our equation, that is the integral property equation, integration of minus infinity plus t, x of tau d tau, we take for the Fourier series C of n divided by j n omega 0, when C of 0 is equal to 0, hence the time integral property is getting to proved. For next property, multiplication or modulation property of Fourier series. Multiplication or modulation property of Fourier series. Here I take for the two signal. Both the signal have periodic signal. The first signal I represent as x1 of t, and the second signal I represent as x2 of t. Why? Because of, if we need to multiply, in the sense minimum we need for the two input. So both the input is represented as a periodic signal. Both the periodic signal, it's going to have for the fundamental period is represented as a capital letter T. In this, both the signal x1 of t and as well as x2 of t, we take for the Fourier series. It's produced the Fourier series coefficient as x1 of t. See, Fourier series coefficient I write as a C of n, and x2 of t, the Fourier series coefficient we should represent as a C of n. So as per the case of Fourier series, x1 of t of Fourier series equal to C of n, and x2 of t, the Fourier series equal to d of n. Then the modulation or multiplication property of continuous time Fourier series state that we may take for the multiplication of x1 of t and x2 of t. It's produce the output of Fourier series is represented as a summation of k equal to minus into plus into C of k d of n minus of k. So due to this case, we represent as the input side, if we multiply it, then output side we get for the convolution of shifted version. That shifted version is represented as n minus of k. Now we need to prove for the multiplication or modulation property of Fourier series. So we take for the definition of continuous time Fourier series as f of s is represented as x1 of t into x2 of t is equal to, so 1 by t integration of t0 to t0 plus t x1 of t into x2 of t e power minus jn omega 0 to dt. This equation we represent as a inverse Fourier case. So inverse Fourier case of the condition I write for the x of t of Fourier series is represented as a 1 by t average value integration of x of t. This is represent for the t0. It's a periodic. That's why t0 plus capital letter. The fundamental period is represented as a capital letter T. T0 to T0 plus T is a fundamental period. Then x of t e power of minus j n omega 0 t dt we should write. Okay. So this equation I am going to utilizing to prove for the modulation or multiplication property. Now this x place we need to replace for the x1 into x2, x1 into x2, that is a multiplication. Then f of s is equal to x1 of t into x2 of t. Then here 1 by t integration of, that is starting of the periodic signal is t0 and ending of periodic signal is t0 plus t. Here the x place we replace for the x1 of t into x2 of t e power minus jn omega 0 t dt I should write. Now we may take for the Fourier case of the condition of x2 only. What is that? x2 we write for the Fourier series condition. So the 1 by t integration of t0 to t0 plus t, x1 we take it out, then x2 of t I should write as a k equal to minus into plus into c of k e power j k omega 0 t. Here I use for the k. So previously what we are using remaining, what about the remaining property we are using for the n here. So if you are using k, Here also you can use the k, e power j k you may use. Okay. Then after, what is the remaining thing? E power minus jn omega 0 to dt. Now this summation, what will be happen? The k equal to minus into plus into, we can merge it for the this n as well as of e power j k omega 0 to what will be? So c of k e power j n minus of k, we can simplify for this e power condition minus j n minus of k omega 0 t dt is represent. Now by rearranging the order of integration as well as of summation, we may write as a, this summation doesn't affect from the differentiation, we take it out. The c of k is also will be represented the Fourier series coefficient, we take it out. What the remaining is that this portion and this portions are remaining is that we can rearrange both integration as well as of summation. So I should write as a 1 by t, that is Fourier series of x1 of t into x2 of t is equal to k equal to minus into plus into c of k 1 by t integration of t0 to t0 plus t x1 of t e power j n minus of k omega 0 t dt I should write. Now as per the statement of our Fourier condition, the x of t I write as a summation of n equal to minus into plus into c of n e power j n omega 0 t. So here also n, here also n, that's why we write as a Fourier series of x of t is represented as a c of n. So if based on the n we write, but for here it's shifted for the n minus of k. Okay, here is represented as n. So I should write the equation as a d of n minus k. The d of n minus k came from here. D of n minus k is equal to 1 by t integration of t0 to t0 plus capital letter t x1 of t e power j n minus of k omega 0 t d of t. This value only I should write for the d of n minus of k. Now we represent for the multiplication of Fourier series condition x1 of t into x2 of t, summation of k equal to minus into plus into c of k, that will be doesn't change. So this portion, this entire portion, we should write as a d of n minus of k. So now finally we represent for the multiplication property or modulation property x1 of t into x2 of t, we take for the Fourier series, summation of k equal to minus into plus into c of k d of n minus k. Hence the property is getting to proved. Next case, convolution property of continuous time Fourier series. So we know the convolution case of signals. What the convolution case of signals? You take for the two signal, we make it to convolute, then it's produce the output as a convolution response output. Okay, but here convolution property of continuous time Fourier series is represented as a two function, that means two periodic signals. We take x1 of t and x2 of t. We take for the x1 of t. Both the signal is represented as a periodic signal with fundamental period is represented as a capital letter T in time domain is equal to multiplication of their Fourier series coefficient in the frequency domain. So this is a statement of convolution property of continuous time Fourier series. It means Fourier series of the convolution of two function x1 of t and x2 of t in time domain is equal to multiplication of their Fourier series coefficient in the frequency domain. So previously we studied, if we multiply for the signal, then its produced output is a convolution. Now this property is represented as, if you convolute for the signal, the output of Fourier series represented as a multiplication of frequency domain. So that is Fourier series coefficient multiplication with frequency domain. Now we need to prove for this property. That's why what we are doing, we take for the two different signal x1 of t and x2 of t. Both will be have the same character. That means periodic signal. x1 of t and x2 of t is a periodic signal with fundamental period is represented as a capital letter T. The Fourier series coefficient of x1 of t is represented as a c of n and x2 of t is represented as a d of n. Now as per the statement of Fourier series, I should write for the Fourier series as a mathematical value. Then x1 of t, take the Fourier series, is represented as a c of n. Then x2 of t, take the Fourier series, its producer coefficient of Fourier series coefficient is dfn. Now, next, the convolution property of continuous time Fourier series, we state that x1 of t convolution of x2 of t is Fourier series of capital letter T, C of n and D of n. So, this T is represents a fundamental period into C of n and D of n. That means this is multiplication. Now, if you do for the convolution of Fourier series condition, the output is represented as a multiplication of Fourier series coefficient. But in this case of multiplication property, if you are doing for the multiplication in the input side, it's produce output side of Fourier series as a convolution output. Now we need to prove for this case. Okay, by taking the definition of Fourier series, we should write for the x of t is represented as a, that is Fourier series x of t is represented as a integration of, that means before that we take for the average of fundamental period, that is capital letter T. Integration of starting of signal is represented as a T0 plus fundamental period, that is we do for the only one period. Then after we write for the x of t e power minus j n omega 0 t dt we should write. This case we replace for the x of t into convolution signal. What is that convolution signal? x1 of t convolution of x2 of t. So here I write for here Fourier series of x1 of t convolution of x2 of t is equal to the average value of 1 by t integration of t0 to t0 plus capital T x1 of t, where the x of t, here also we have the x of t in the equation of Fourier series. There you can replace for the x1 of t into x2 of t e power j n omega 0 t. Remaining and all it's similar. Now we take for the period, that is I represent by the 0 to t. Okay, so it's represented by the 0 to t, or we take for the t0 to t0 plus capital T. Both are similar. We'll have the same period. Okay, so now I should write for the our equation Fourier series of x1 of t into, that is convolution x2 of t is equal to 1 by t integration of 0 to capital letter T. Here this is we replaced. Why? Because of it's both are similar. That's why I write as a 0 to t x1 of t convolution of x2 of t e power j n omega 0 dt. Now, by definition of convolution integral of periodic signal, we know well that is a LTE system. We do for the convolution when it's going to produce the output of convolution of two signal x1 of t convolution of x2 of t is equal to integration of 0 to t x1 of tau x2 of t minus of tau d tau. Okay, this is a convolution equation of LTE system. The period is represented as 0 to t. So that's why the periodic signal convolution we may represent. Linear time invariant periodic signal convolution equation we represent as x1 of t convolution of x2 of t is equal to integration of 0 to t x1 of tau x2 of t minus tau d tau. This one we need to substitute for our equation. Whether this equation we can shift it for the shifted version is going to happen for the x2 of t also, x1 of t also. Both the equations are similar only. Okay, we can write x1 of t convolution of x2 of t. We write whether the shifted version is going to happen for the x2 of t or x1 of t. Both the equation is going to similar condition. Now, by substituting the value of x1 of t convolution of x2 of t from the equation as here, right side only we are going to substituting from the equation. So this side we don't need to change. So 1 by t integration of 0 to t, then 0 to integration of 0 to t x1 of tau x2 of t minus tau d tau e power j n omega 0 t. So this place only we are going to substitute. That means what is it? Here we write as a x1 of t convolution of x2 of t. This value is equal to integration of 0 to t. If we need to convolute x1 of tau x2 of t minus of tau d tau we write. So that equation we write here. Then rearranging the order of integration. We need to rearrange the order of integration. 1 by t is present. Integration of 0 to t. this x1 of tau doesn't affect. So I take it out for the x1 of tau. So after that, integration of 0 to t x2 of t minus of tau e power j n omega 0 t dt and d tau. Now I should write for the t minus of tau. This t minus of tau I make to write for the t0. Now this case dt by dt0. This one it will be the t condition d by dt is going to cancel. So finally we got for the dt is equal to dt0. dt0 we got. We can substitute for all the values from this value and this value from this equation. So now the conversion case, Fourier series of x1 of t, conversion of x2 of t is equal to 1 by t integration of 0 to t x1 of tau. This one we can write it same. So this place only we changed. Integration of minus t to t minus of tau. Why? Because of we changed for the interval. So x2 of t0, this value, then e power jn omega 0 t0 plus tau. So here is t is there, then we can replace for the based on this. What is the t here? So t minus of tau equal to t0. Then t is, we should write as a t0 plus of tau. We write. So t0 plus of tau I write here. So here dt, you differentiate with the t, then dt is equal to dt0. Here I write for the dt0, d tau. Now, so here what will be going to happen? Simply I multiply with the 1t. Okay, multiply here, multiply with the 1t. That means you can divide it by the 1t here. So t into 1 by tau t integration of 0 to t x1 of tau e power jn omega 0 tau. This value I can split for like this one. So e power minus jn omega 0 t0 as well as of e power minus jn omega 0 tau. So now this value where the tau is present, x term it will be tau, we can replace this. For here t0 is there, then you can represent for the xt0. Okay. Now what will happen? So 2 integration is going to happen. It will be multiplied with 1 by t. Here I multiply with 1 by t. So this case, what will be? This entire term we represent as the c of n. This term is represented as a d of n. Okay, this is c of n. Now finally we write for the Fourier series of x1 of t convolution of x2 of t is equal to this t is a fundamental period is going to multiply it. This term is represented as c of n. What is that term? 0 to t x1 of tau e power jn omega 0 to d tau represented as c of n. This term is represented as a d of n. What is it? 1 by t integration of minus t to t plus tau x2 of t0 e power jn omega 0 t0 dt0. So I write as that value equal to d of n. Okay. Now finally we can represent for the convolution property of Fourier series is x1 of t convolution of x2 of t take Fourier series, we represent for the capital letter T c of n d of n. So if we convolute the Fourier series is it will be produce a multiplication with fundamental period. This is called for the convolution property of Fourier series. Next we go for the Parseval theorem and Parseval identity. So here also we take for the 2 different kind of signal, that is x1 of t and x2 of t. Both have the physical character similar. This physical character in the sense the x1 of t and x2 of t is a periodic signal. Its fundamental period we take for the capital letter T. Then x1 of t Fourier series value is represented as a c of n. Okay, Fourier series represented as a c of n, and x2 of t Fourier series represented as a d of n. Okay, as the Parseval theorem statement, if you multiply with both the signal x1 of t and x2 of t with complex conjugate, its produced output also will be represented as a complex conjugate of Fourier series coefficient. It's represented as a Parseval theorem. That will be I express here as a Parseval theorem of continuous time Fourier series statement 1 by t integration of t0 to t0 plus tau. That is this is starting and ending interval of our periodic signal. x1 of t x2 of complex conjugate of t dt. This value is equal to summation of n equal to minus 2 plus into c of n d of n we represent. For the complex value, we should take for any one. You take for the x1 of t or x2 of t. So this is represents a Parseval statement. Then Parseval's identity of Fourier series represents as we take for the x1 of t and x2 of t is going to have same signal. That will be I write as a x of t. See here, x1 of t equal to x2 of t. x1 of t is equal to x2 of t is represented by the x of t. Now I should write for the 1 by t integration of t0 to t0 plus t x1 of t, that is x1 of t into x1 star of t. I write mod of x of t we may write. So this value, okay, so x1 of t into x star of 1 of t I represent as a mod of x of t whole square we make to write. So this value we can substitute for the condition of Parseval theorem. So 1 by t integration of t0 to t0 plus t mod of xt of whole square dt, that value is equal to summation of n equal to minus n plus d mod of c of n whole square. This is represented as a Parseval identity. Now in this Parseval identity, both the signals are similar, but both the signal we take for the any one of the signal in this both the signal any one of the signal we take it for the complex value. So that I will write as a x1 of t into x2 star of t mod of x1 of t whole square. So this value we can substitute for the Parseval identity condition. So both the signal in the similar in the sense as per the Parseval theorem, integration of that is average value of 1 by t integration of t0 to t0 plus t x1 of t into x2, that is x1 star of t dt we write as mod of x of t whole square. So if we take for the Fourier series of this condition, what the output, this both the signals are similar, that's why c of n also will be other similar, that is that c of n into c of n. So that will be I write as a summation of n equal to minus plus into c of n mod square. Now we need to prove. First we go for the Parseval theorem or Parseval relation or Parseval property. What that Parseval property or Parseval relation or Parseval theorem is represented as a 1 by t integration of t0 to t0 plus t x1 of tau t x2 star of t dt. That will be equal to, if you take for the Fourier series, then it's represented as a summation of n equal to minus 2 plus 2 c of n d of n star. Now from the definition of Fourier series, I should write for the LHS side, or that LHS, or this is a LHS side. 1 by t integration of t0 to t0 plus tau t capital letter t x1 of t x2 star of t dt. So this value I should write for x1 of t as 1 by t integration of t0 to plus t0 capital letter t. This value summation of n equal to minus into plus into, that means x1 of t c of n e power j n omega 0 t, that x2 star we take for the same time, the x2 star of t dt we write. Now rearranging the integration and the summation of right hand side of the equation. So right hand side what will we do, the integration, that is summation of c of n is represented as a linear constant coefficient of Fourier series. We take it out. Summation of n equal to minus plus into c of n 1 by t integration of t0 to t0 plus capital letter t x2 star of t e power j n omega 0 t dt I write. Okay. So now what our Parseval relation statement, what will be happen, 1 by t integration of t0 to t0 plus capital T x1 of t x2 star of t dt we write, that is equal to summation of n equal to minus c of n 1 by t integration of t0 to t0 plus capital letter t x2 star of t e power j n omega 0 t dt we write. Then now that x2 star of t I take it out for the outside, that is whole case, the right side only I should explain, n equal to minus plus c of n 1 by t integration of t0 to t0 plus t x2 of t, here is star is there, I take it out here, That's why automatically here getting for the e power j getting for the minus value. Okay. So now I write as a n equal to minus plus into c of n 1 by t integration of t0 plus t x2 of t e power j n omega 0 t dt. Right. So now this entire term, what is it? Is represented as a d of n. Okay. So that star is there. I should write for the star. Now I can simplify for the equation, and integration of that is 1 by t, that is integration of t0 to t0 plus t x1 of t x2 star of t dt is represented as a summation of n equal to minus plus c of n e d of n star. So this is called for the Parseval theorem. We should prove. Next, Parseval identity. How to prove? Here we take for the both the signals are similar. x1 of t equal to x2 of t equal to x of t. Both the signals are similar. Now the Parseval relation become 1 by t integration of t0 to t0 plus t x of t x star of t dt is equal to summation of n equal to minus plus c of n c star of n I write. So now we can simplify for this equation. So we know that is x of t into x of t star. This value equal to mod of x of t whole square. So here 1 by t integration of, that is the left side, integration of t0 to t0 plus t x of t x star of t dt is equal to, in the right side, summation of n equal to minus plus into c of n star. Okay, we write. So now we know this value. We can write that c of n star c of n is equal to mod of c of n square. You can substitute for this value into our equation for the Parseval identity condition. So what will be happen? 1 by t integration of t0 to t0 plus capital letter T x of t mod square dt is equal to summation of n equal to minus plus into c of n mod square. This is represented as a Parseval relation identity. Up to this much, the property of Fourier series is over. So what are the properties are present? The properties represent as a Fourier series properties represent as a linear property of continuous time Fourier series, conjugate property of continuous time Fourier series, then conjugate symmetric property of continuous time Fourier series, time shifting property of Fourier series, time reversal property of Fourier series, time scaling property of Fourier series, time differential property of Fourier series, then time integral property of continuous time Fourier series, convolution property of continuous time Fourier series, and Parseval theorem and Parseval identity of Fourier series. We studied for Fourier series properties. So up to this much, Fourier series properties over. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.